Hello, we have been completing the square, and now we're going to see why we've been completing the square and how that shows up on the graph of a quadratic function. So let's just recap quickly the two forms of the quadratic function that we already know. The first one being standard form, that's where it's written as ax squared plus bx plus c. Benefit of having this form, well, you can see that it's a quadratic. You can determine if it opens up or down. So up if A is positive, and it opens down if A is negative. Another thing, we can pick out the y-intercept is the point 0c. So those are things that we can pick out just from this standard form. The other thing was we went from standard form to intercept form or factored form. And this was when we factored. So we took out a GCF maybe, and we had an x minus m, x minus n. Right? We had two binomials, and I put these as opposite signs because one of the benefits of having it in factored form is that we can pick out the roots. The roots are the opposite sign of whatever's in parentheses, m0 and n0. So you can pick out your roots. You can still determine whether A opens up or down also, by the way. Those are two things we can still pick out. But if we do that, then we also know that our axis of symmetry is the average of our roots. Ooh, one thing we need to point out in standard form, our axis of symmetry is x equals opposite b over 2a. So again, I'm writing AOS for axis of symmetry. So our final form here is vertex form, and the one thing, we're going to write the benefit first here, we can pick out the vertex. And what we've been doing is we're going from standard form to vertex form by completing the square. So we've factored out something in front. I've got x minus h squared plus k. I've written it as a perfect square trinomial. We've compensated by adding or subtracting something, and we've factored out a leading coefficient of a. So again, this is the very same a that will tell us whether it opens up or down, whether it's positive or negative. That number in front is still going to tell us that amount. And now the vertex is going to be, well, we'll fill this out in a second. Let's do a quick example and see if we can pick out the vertex from vertex form. So here is the basic quadratic function, f of x equals x squared. It's graphed on our set of axes. Here's a more complex one, and I know this copied kind of funky, but it looks like this. G of x equals x minus 2 squared minus 4. So we're going to graph this on the same set of axes. Take out your graphing calculator, and we're going to plug in this into y equals, because I want a table of values. Okay, if we plug it into y equals, we get a table of values, and we're going to scroll around until we find the vertex. So pause the video, take time to do that, see if you can figure out where the vertex is so we can graph this thing. We're going to make a table of values and plot it. Okay, so we plug it into y equals, and if we scroll around our table, we get something like this. And you can see that it is decreasing, decreasing, decreasing until it hits a certain point. And then it's increasing, 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 and those values are repeating. So that point that it switches direction is the vertex. The vertex is 2, negative 4, which means the axis of symmetry is at x equals 2. So let's go back and let's plot that point. Was it 2, negative 4? So 1, 2, 1, 2, 3, 4. There is your vertex. I've got an axis of symmetry on that point. And let's plot a couple points above it and a couple points below it. 1, negative 3, 0, 0, 1, negative 1, 2, 3. And what's nice about the axis of symmetry is now I've got some symmetric points. So this is 1 unit away. I'm going to go 1 unit away on that side. This is 2 units away. I'll go 2 units on that side. Now let's graph this. Okay, so we've graphed g of x. I'm just going to label that g of x. I'll label this one f of x, just so we know which one's which. Whenever you graph more than one function on the same set of axes, you always want to label it somehow. Okay, we graphed it. What is the turning point of g of x? Well, that is the same thing as what is the vertex, and we determined that to be 2, negative 4. And now here's the kicker. Where do you see this in the function's equation? So look at your original equation. G of x equals x minus 2 squared minus 4. And our vertex is 2, negative 4. Well, one thing I notice is that my y value of negative 4 is here. And 2 is, well, I've got a negative 2. So this is the opposite sign of my x value. It was in the parentheses with my x. And this is my y value. So this was my x, and this was my y of the vertex. So let's go back to my previous page. It's the same page for you. The vertex in this general form, that's why there's a minus inside your parentheses. Your vertex is HK. So the sign of what's in parentheses is always the opposite sign. And then whatever K is, whatever that sign is, just stays. So that stays. So inside your parentheses is with your x, so it's your x value. And then outside your parentheses is your y value. So that is it. That is the main point of this entire video. So let's just look at an equation, and I want to pick out the vertex. So this is written in vertex form. You've already completed the square. So what's the vertex? Well, I've got an x minus 8 in parentheses, so I'm going to take the opposite sign, just like as if it was a factor. So I'll have 8, and then 5 is just 5. So there's my vertex. Another tidbit, if you know your vertex, then you know your axis of symmetry is x equals 8. Just a little extra piece of information that you can gather. Let's go back. I don't have an a value here, and so it's positive. We know that this opens up because there is nothing in front of my parentheses, and it's assumed to be just a positive one. Cool. What about this one? Number 2. Inside my parentheses, I have a 2, so my vertex is going to be a negative 2. Outside my parentheses, I have a plus 1, so that's going to stay. So the vertex is going to be negative 2, 1. Again, we know the axis of symmetry is x equals negative 2. I don't want you to be writing the axis of symmetry as just a value. Write it as the equation of the line, which is an x equals. That's it. You've got a bunch of other examples, but I'm pretty sure that you can catch on. So, this is a nice short video. Bye.